All right, Trevor, take it away.
Great. Well, welcome all. I'm Trevor Hardy at Pacific Northwest National Lab, and I'm going to be talking about the Helix standardized interfaces we've been developing, designing, maybe as good a word as that, over the this past round of funding for Helix. So let's make sure I click in the right place. There we go. So the goal with the standardized interfaces at its core is really to enable interchangeability of simulation tools that perform similar functions. So you can kind of see in the diagram there on the right, if we're able to get good standardized interfaces in between with all the tools for specific use cases, you can imagine the situation where you can mix and match any tool on the left with any tool on the right to, for example, run a T&D power flow, a combined power flow. So the standardized interface then allows us to define the Helix connections and the Helix side of this information such that the tools don't know who is actually doing the simulation in the other part of the co-simulation, which specific simulation tool is being used, and that the information just continues to flow. And kind of like with software design, right? There's kind of a layer of abstraction there that, and sometimes we talk about that as kind of the federate layer, right? The federate and its interfaces are common, such that, for example, GridLabD or OpenDSS can be the actual simulation tool underneath, but they all are posting the information that they're sending out on the same federate interface. And so whoever's on the other side of PowerWorld or PSSE or whatever can get that information and use it, and it doesn't need to know what's going on underneath. So kind of that, again, software design, encapsulation, all that kind of idea. The real dream, or maybe the end goal dream in some regards, is that this becomes very well accepted, standardized, implemented, and becomes completely invisible. Like users you could just click a button that says use standardized interface for this tool, and they can join the co-simulation, and they don't even have to set up anything, right? That's because it's already defined for this use case what needs to be set up. Helix is through the standardization process, the developers who have done the integration for that tool into Helix or with Helix know what those publications and subscriptions need to be, and that just one click button and you're done with the analysis. So that's the dream. And interchangeability, abstraction away from the specifics of the simulation tool. Yeah, and we'll talk more about that. But one thing that can kind of, actually, I think it's, yeah. So here's the parts of the standardized interface, and the first one, the point I was about to get to is, it requires us thinking about the tools in terms of specific use cases, or you can think of this almost as like specific analyses that want to be performed. So the example I have there on the right is pulled directly from the document we've been developing, and this is the definition for a standardized the standardized interfaces needed for a T&D power flow. And you can see the signs here. The federates involved in this case, there's a transmission federate and a distribution federate. There are the inputs that are required, and here are the outputs, and you'll see references in there to the specific definitions, which we'll get to in a second. The key to making the simulation tools interchangeable in some respects is that we've got to all have this functionality possible. In the case of our power system simulation tools, solving a power flow is kind of table stakes. You're pretty much not a power system simulator if you can't do that. So we are requiring essentially that if you want to use the standardized interface and participate in this use case, you have to be able to execute that function. There are, in all cases, all tools probably do more than that, and that's okay. We don't define those additional functionalities as what is required for this use case. There are other use cases that have different requirements, and some simulation tools that you could use, say, for T&D power flow may not be able to participate in those use cases because they don't have the required functionality. And that's, so again, we think of this in terms of these use cases or these specific analysis needs that we have. Next, as referenced above, or in the use case definition, each of those inputs and outputs has a specific interface definition that provides all the nitty-gritty details about how this Helix interface needs to be set up. Is it a publication, subscription, input, endpoint, all those kinds of things. As you can see down here, We provide a standardized naming convention for the interface. We tell what type it is, it's a value versus a message interface, units, data type, all that kind of stuff, and then tags, which we'll get here to in a sec. This doesn't have one. This GUID that we put in here is based on the assumption that the underlying model has standardized names for buses and lines and things like that. So in this case, we're defining a voltage at the point of common coupling between the transmission and distribution, for example. And the assumption is there is a model, a standardized model that has a name for that bus, and you would insert that name here in this GUID. So this GUID does not to be confused with maybe a more specific use of the term. You know, there's packages out there that will generate GUIDs, and there's things, different conventions and different other information models that define what the GUID is. This is really in the general sense that this is a unique identifier for, in this case, the nodes in the network, such that, and everybody agrees that what that name would mean as applied to a specific bus. And therefore, we can all agree that when I talk about the voltage at bus 13, we all know exactly what bus that is, and there's no confusion. So there's a bunch of these interfaces that are defined. Obviously, not every use case uses every interface, and not there are more interfaces, generally speaking, than use cases. And so the definition of the use case or the analysis need, basically, once we have a deep enough library of these interfaces defined, it shouldn't require anybody wanting to do a new analysis. In general, they should be able to get most or all of the interfaces they need from the existing definitions and maybe add one or two custom ones. So again, there's a little bit of kind of, again, layers of abstraction, this time in terms of the definition of how these standardized interfaces. The use case is separate than the interface, but they work together. The last item is a feature that Helix added support for relatively recently, tags, which basically allow us to assign metadata to an interface point. You saw in the definition for the voltage that there was no tags defined. Some of the tags, it makes sense to, or some interfaces that make sense to have this tag information associated with it because it would be commonly used. So for example, we defined a tag that can be used to define a device setting type. Depending on different devices and different settings they have, those settings may be either we gave the values, possible values are Boolean, true, false, on, off, discrete, setting 1 through 7, or a continuous one, regulate voltage to 32.3 or something like that, right? So by having this tag, we require, if an interface requires a tag, calls out a tag, it provides a way for federates on the other side that are connecting to that interface to understand the nature of the information they need to send. For example, maybe you have a controller federate that's adjusting a voltage regulator. Does the controller, in our dream world, right, where it's one click and you just, you don't have to do any configuration of the federate, in that case, the controller has to be smart enough to understand what kind of control signals it can send to that voltage regulator. And so this tag then provides a way in which that federate can query the interface, get this tag information, and then understand, okay, I need to be sending, values 1 through 7 or a continuous value, and it can configure its output appropriately from that. So all of this is designed to kind of support putting the smarts into the federate code so that it can configure itself using this kind of standardized way that all our Helix federates can support this. So here's this workflow we'll get to in a second. We realized at one point that there's a need, in some cases, taking maybe the voltage regulation example, you can imagine that there's a voltage management federate, a controller of some kind, and it needs to look at the voltage for its algorithm to work, it needs to look at voltage at maybe 5 or 6 specific points in the network. But the federate that's providing those voltages, it has maybe thousands of voltages or hundreds of voltages, right? That could be published. So one option would be, hey, let's just publish all of those, and then the controller federate just picks off the ones it needs. We haven't done a ton of testing, but our testing so far kind of indicates that that leads to a lot of, particularly in larger models that you might imagine, a lot of unnecessary churn and essentially really clutters up the ability to understand and see what is going on in the federation. If you have thousands of publications and almost none of them are being subscribed to, it makes comprehending the federation a little bit more challenging. So we came up with this idea of a dynamic configuration. The features to support this have been recently added into Helix. So this is now something that's possible. We wrote out this definition prior to the features being available. And as I'll get to, we haven't really tested them extensively, but here's the idea. So during the creation phase, that is prior to calling enter initializing mode, federates use what we call the Helix command interface, which is a way to send asynchronous messages to tell other federates, hey, these are the interfaces I need you to make for me. And we've defined a standardized format, this JSON string right here, and can send that over. Once a federate has seen all the interface messages or interfaces it needs created, it can then call enter initializing mode iterative. The reason we're calling this iterative is it allows federations or allows federates to make sure that they've received all their commands and to kind of iterate in this initializing mode to continue receiving commands and make sure that they're getting all the messages about who needs what. After entering initializing mode, each federate reads the commands it has received and then sets up those interfaces by and then once those have been created, each of those things, there's kind of some choices. One, things could fail. That's this black path. Somebody sent the distribution federate, hey, I need to know the status of your nuclear power generators or whatever. And it's like, oh yeah, we don't have those. So there's an ability in API to call a global error that will basically end the co-simulation because the configuration was going to fail. Alternatively, basically, you can go into the normal initialization process, either skipping initialization entirely and just jumping to execution mode, which is time 0, or continuing to iterate and initialize your model state with other federates that are doing so in this initialization period. So again,
you've got about a minute left.
Perfect. We haven't been able to test this. So here's the state of the development. The multi-site demonstration was kind of our first big coming out with these standardized interfaces. We've been using them other ways, but the multi-site demonstration was able to use the definitions of what the interfaces are and had generally good success with that. There's still some modeling mismatches that have to be handled. If the classic one we have here, a natural gas federate can tell you how much gas is coming out of it, and a power system federate needs to know how much electrical power relates to that gas. Nobody's really modeling in this kind of situation, modeling that energy conversion from chemical energy to electrical energy. So there's a gap that needs to be addressed. As I mentioned, we haven't really tested the dynamic configuration process, so there's certainly bugs that need to be worked out there. And then lastly, again, the multi-site demonstration, as the users of this have kind of realized that the standardized interfaces are necessary for this dream of the one-click configuration, but there's other things that need to be standardized as well to really make that the case. And I think that's all I got. Yeah. Any questions?
Thanks, Trevor. Yeah, we've got about 9 minutes for questions. So feel free to just pop on or raise your hand or type something in the chat. Looks like there's a question from Andy.
Yeah, hi. So going back to the having the federates use the send command to tell other federates what inputs and outputs it needs. So is the idea there that a federate that has the idea is that you just created one, in a simple T and D case, you had a transmission federate and you bothered to define the inputs and outputs for that transmission federate, but you didn't for the distribution federate. So the transmission federate is saying, hey, I'm going to need you to create, see, I have these outputs, so I'm going to need you to create some inputs that correspond to the outputs that I'm going to be sending. Correct? Is that the general, federate response, I guess, federate responsibilities in a dynamic configuration case?
Yeah, generally that's the idea. For the specific case you brought up, and this is again kind of a gap in the standard, like a T&D power flow, there shouldn't be a need to do dynamic configuration. Everybody should know where's the point of common coupling. That should all have been able to be defined ahead of time. You can, again, the example maybe is in a voltage regulation use case, what voltages those controllers need is likely to be not standardizable at all.
Right. Yeah. So okay, I got you. So in the cases of where there's no standard federate role of input and output, basically,
right,
where
like,
yeah. So something for a custom use case situation.
Yeah, with the voltage one, right? We know the voltage manager needs to measure some voltages somewhere.
Right.
We don't know which ones it's going to need. So that's where the need for dynamic configuration. That said, what you're talking about, I mean, we haven't done enough work, but you can imagine a situation where we realize, hey, this dynamic configuration thing works really well. Maybe we don't even for the T&D power flow. Maybe we don't even need to worry about calling it out. Just have the federates configure themselves. We've written enough smarts into them that if they know they're doing the T&D power flow use case, they can just work it out.
Right.
Maybe.
Yeah. There's still the burden of defining at least the inputs and outputs for one in order for the inputs of the other,
Yes.
the inputs and outputs of the other to be determined and requested.
Yeah.
Thanks. Looks like there's also a question from Abhijit.
Hi, Trevor. I have one question on during the dynamic simulation, let's say in the transmission system or distribution, the type of contingency that can arise may vary. So how about like the inputs and outputs that we are querying? Can they be changed during the time of those specific contingency?
When you say contingency, what do you mean specifically?
Let's say you have a big transmission system, and in one specific area you have an outage, and
Okay.
you want to regulate that outage in that particular area, but after some time you would have outage in some other area. So how do you change your set of input and output from this area to that area?
Yeah. Oh, that's interesting. So we haven't thought at all about use cases whose definitions, the required interfaces change in simulation time. So we don't have an answer for that right now. It's a good question. If you knew ahead of time where that outage was going to change to, where you needed to be watching, you could set up both and then pay attention to one and then pay attention to the other. But yeah, that's an interesting question, actually.
Great. Looks like there's a couple of things here from chat. I believe some of them partially answered, but just to make sure everybody's in the loop, Joseph had asked, any plan to ever batch the federate interfaces, i.e. more than just one voltage control for one bus or for a subscription?
Oh, yeah. So we have talked about that, and I wouldn't say the idea is off the table. And if I'm understanding correctly, the idea would be, we have one voltage you subscribe to for the distribution system, and actually inside that information is a bunch of specific voltages, right? The reason we haven't gone that way right now is it allows us to be more specific in detail. The Helix. The existing Helix definitions for an interface allow us to do things like assign units, assign data types, things like that. Now you can imagine for a voltage, those things might be consistent across all the voltages. So it might work in that case. In other cases, we would expect more heterogeneity And that there's some ways in which that kind of doesn't really mess up, but it is inefficient in terms of helix. So for example, if you publish all the voltages under one helix interface, the voltage publication, anytime any of the voltages change, you would have to republish that. And that would require the subscriber to go through anytime any of them change and look and see that the ones I actually care about change. So that having the granularity provides for some computational efficiency. But I can imagine there might be some use cases where it would make sense to bundle those.
Yeah, and I think I would just add the idea that, you know, as Trevor described, this is something we're excited to have, but it's really like a, you know, version 1 or version 0.1, and we're hoping to evolve it over time. And you know, to the extent it allows, we'd love to have other people's contributions and views and ideas and ways to advance this type of capability. So keep talking.
I would add that you know, that the capability to bundle or you know, bundle multiple measurements or, you know, voltages or what have you under a single endpoint is already capable through Helix. It's just there's no standard you know, way of handling that. You know, it's very tool specific. For that, D does something very specific for that, and it uses a JSON schema to identify which property and value and the associated values with those are being, you know, bundled together, and then it's the responsibility of the other tool to you know, parse that data and then figure out what to do with each piece, or only grab with the pieces that it's interested in.
Yeah, I would I think part of this is, you know, it doesn't have to, I agree that like this would decrease heterogeneity. But I guess it doesn't really have to be as baked in. Like if there is a way to have lists of Helix interfaces and work with those, I think that could be made more efficient. So you wouldn't have to send on each one. You could just send for all or receive on all.
Yeah, that sounds very interesting. I know this is not exactly what you're talking about, but something that's somewhat relevant is there is wildcard support if they're still individual messages, but you can have an easier process of collecting the messages or values that match various, like, well, you know, whatever regular expression style matches. So that doesn't quite get at the idea of there being a list that's gathered together as a single data transfer, but there are some support for having fewer things to have to request. Anyway, it seemed like a great idea. We're reached the end of our first session here. So if you have any further questions for Trevor, feel free to follow up, or you can probably be monitoring chat for the next little bit too. But thanks so much, Trevor. Definitely a really great project here, or portion of the effort here. And I'm going to go ahead and pause or restart the recording, so each of these sessions is separate. Let me do that.